All right, everybody. So today we're going to do decomposition reactions. And I think that you will find this slightly easier than the synthesis reactions simply because we've already done synthesis. And decomposition is simply synthesis going the other way. So it's basically just a backwards version of synthesis. So what we're looking at, if you flip over to your reaction rules, you'll notice here's A, B, C, and D. Here's A, B, C, and D. Okay? Here we made a binary compound. Here we're decomposing a binary compound. Okay? And it's literally just everything flipped around the other way. All right? So we put in our notes these little symbols for, sort of what's an oxy acid, what's a base, what is an oxysalt. So those same ones can go over here. So B is the decomposition of an oxy acid. So you're going to be starting off with something that is H and then a non-metal oxygen polyatomic ion. Here we're going to be decomposing a base, so that means you're going to be starting with a metal attached to a hydroxide ion. Okay? And then for D, we are decomposing an oxysalt, which is a metal with a polyatomic ion that is a non-metal oxygen. Okay? And you'll notice that the products are what we started with over here. So when we take apart a binary compound, we end up with two elements. Okay? So let's highlight that here. Okay? So a binary compound is going to yield two elements. See, two elements yields a binary compound. A binary compound yields two elements. They're opposites. An oxy acid is going to yield a non-metallic oxide and water. And again, you're going to reverse the note. So we'll go over that. So we use this note down here. High oxidation number is an 8. Low oxidation number is an 8. Here, we're going to look at what the polyatomic ion is to figure out whether we're going to use the high or low oxidation number. Okay? Decomposition of a base. So we're starting with a base and we're going to end with a metallic oxide and water. An oxysalt, we're going to get a non-metallic oxide and a metallic oxide. All right? And again, here we're going to reverse this note down here about what it is. All right? So I've got a couple of examples. We're going to do an example of each type. So for the first one, type A, we have lead-4 oxide yields. So let's start by writing the lead-4 oxide. We have lead is Pb. The charge of it in this case is 4 because of the Roman numeral. And then we have oxygen, O. Oxygen has a charge of 2 minus. Now here, if we crisscross this, we're going to get 4 on the oxygen and 2 on the lead. That can be reduced because both of those are divisible by 2, excuse me. So we're going to divide both of those by 2. So lead has a 1, oxygen has a 2. Okay, so we have PbO2. And then we need our arrow. So we are going to take this apart into simply the two elements. We have a metal oxide, but nothing else. Okay? And there's no decomposition reaction that starts with a metal oxide. Not a single one of them starts with a metal oxide. So this must be a binary compound. So we're going to take it apart into two elements. Okay? So that means we're going to have lead by itself and then oxygen by itself. Okay? Now, metal by itself, we simply write the symbol for the metal and leave it alone. Non-metal by itself, we have to ask ourselves if that's on the Hofbrinkel list. And this one is. Oxygen is a Hofbrinkel, so this is going to be O2. Okay, so this would be the correct equation. Now we need to make sure that it is balanced. So we have 1 lead, 2 oxygen, 2 oxygen. This is balanced. Okay, so for a binary compound, you're simply going to take it apart into the two elements that it is made out of. All right, so then we have phosphorus acid yields, okay? So phosphorus acid, OUS, is the ITE, phosphite. So of course it's an acid, so it's going to start with hydrogen. Then we're going to grab our polyatomic ions chart and we're going to look up phosphite, which is this right here. It's PO3 with a 3- charge. So we have PO3, and then that 3- charge from the phosphite, we put that as the subscript for the hydrogen. So that's H3PO3. Okay? And then we're going to give this a yields. Now let's go over to our reaction rules and see what happens to an oxy acid. An oxy acid, again, hydrogen, nonmetal, oxygen, that's what we had. We had hydrogen, phosphorus, and then oxygen. It's going to make a non-metallic oxide and water. So our non-metallic oxide is going to be phosphorus and oxygen. So we're going to put P and O, and we're going to come back to that in a minute. And then they also said it makes water. So we'll put the H2O over here. Now, we got to figure this guy out. So what we're going to do here is we're going to go backwards with our note 1. So we have the ITE polyatomic ion here. So if we go over here to our note, the ITE polyatomic ion is the low oxidation number. So now we go to our oxidation chart, and we're going to find phosphorus. Remember, the negative is for when it's an anionic compound, so we're looking at the 3+ and the 5+. We want the low one, so that's going to be a charge of 3+. Okay? So for this, our P has a charge of 3+. Our oxygen has a charge of 2-. So we're going to crisscross that. The 3 from the phosphorus goes to oxygen. 2 from oxygen goes to the phosphorus. Okay? So that is the correct equation for the decomposition of an oxy acid. Now we need to make sure that this equation is balanced, which it is not. Okay? So on the left, we have 1 phosphorus, and on the right, we have 2. So we're going to put a 2 in front of the H3PO3. Okay? That's going to change the phosphorus to 2, but that's also going to change the hydrogen to 6. So over here, we've only got 2, so we're going to multiply that by 3 to give us 6 total hydrogen. Now for the oxygen, I have 3 here plus 3 here for a total of 6 oxygens. Over here, I have 2 times 3 for a total of 6. So my oxygens are balanced now that we balanced everything else. So that's why I always say, if you've got something in more than one spot, like this oxygen is in 2 spots, always do that last, okay? Because usually it fixes itself. Okay, so that one's kind of tricky because we have to use that rule to go backwards to figure out, okay, phosphite, that's the low oxidation number, looking up the low oxidation number and then using it to crisscross with the oxygen. All right, the next one is a type C. We have a base, cobalt 3 hydroxide yields. So again, this 3 Roman numeral is the charge of the cobalt, so that's got a charge of 3+. And then we have hydroxide as our ion, and we know that hydroxide is a 1- charge. So the 3 from the cobalt goes out here to the hydroxide. And then we have our arrow. So now let's go to our reaction rules and see what we're going to make with a base. So a base is going to make a metallic oxide and water. Okay, so in this case, our metal is cobalt, CO. And then we're going to put a capital O. And then we have water. Now we can't leave this like this. The charge of the cobalt was 3 before. We're going to keep that charge. So cobalt was 3+. Oxygen, we know from our periodic table, is 2-. So when we crisscross this, this 3 comes to the oxygen. This 2 goes to the cobalt. So then we need to balance our equation. All right, so on the left, I have 1 cobalt. On the right, I have 2. So I'm going to multiply this side by 2. Okay, now that changes everything. So my hydrogen, I have 1 inside times 3, that's 3. times 2, I have 6 total hydrogens over here. So over here, I'm going to multiply this one by 3 to make my hydrogen 6. Now here I have 1 times 3, so 3 oxygens times this 2. So I have 6 oxygens here. On this side, I have 3 oxygens there plus these 3 oxygens here. So this is a total of 6 oxygens. So that's balanced now. Okay, so that one's pretty straightforward. Metal oxide, nothing new. We just crisscross our charges like we always have done, and then we put the water with it. This last one is another tricky one. It's a type D. We have an oxy-salt calcium phosphate. Symbol for calcium is Ca, and then we would get the charge for calcium off the periodic table. Calcium is a group 2 metal, so it's going to have a charge of 2+. Phosphate, Ate, that's going to be the polyatomic ion. So we're going to grab our polyatomic ions chart, find phosphate. It is PO4 with a 3- charge. So when we crisscross this, the 2 from the calcium goes to the phosphate. The 3 from the phosphate goes to the calcium. So Ca3PO4 2. We're going to take this apart. Now let's go to our reaction rules and see what we can make with an oxysalt. An oxysalt is going to break apart into a non-metallic oxide and a metallic oxide. So our non-metal here is P. So we're going to have our non-metallic oxide and then a metallic oxide. So our metal is calcium. So now we need to figure out both of these. I'm going to start with the metal one because that one's easy because we already know our charges. Calcium is 2+, oxygen 2-. So when we crisscross that, it cancels out. Let's deal with this nonsense here. Okay, so this is one where, again, we're going to have to use our rule and walk it backwards. So we have phosphate, PO4, phosphate. So when we have phosphate, ATE, we're going to need the high oxidation number. So we're going to look for phosphate or phosphorus on here. Okay, remember the negative we ignore. We have +3 and +5. The high oxidation number is going to be that 5. So the charge we're going to use for phosphorus here is 5+. Oxygen, of course, is always 2-. So we're going to take the 2 from the oxygen, give it to the phosphorus. The 5 from the phosphorus goes to the oxygen. So this would be diphosphorus pentoxide. Okay? And then, of course, the last step here is to balance our equation. So let's start with our metal. We have 3 on the left and 2 on the right. I'm sorry, 1 on the right. So I'm going to multiply this by 3. For phosphorus, I've got 2 on the left and 2 on the right. Now let's count our oxygen. I've got 4 times 2, that's 8 total oxygens on the left. I have 5 here, and then I have another 3 here, so that's going to give me 8 oxygens on the right. So that is balanced. Okay, so these are a little bit on the tricky side simply because we have that same issue with the metal oxides and having to figure out the charge. Okay, so make sure that when you're doing these, you're looking at what am I starting with? What am I starting with? Okay, binary compound, oxyacid, base, or oxysalt. Okay, and just use those rules.